The atmosphere of Earth envelops our globe like a thin, imperceptible veil, safeguarding and nourishing everything beneath it. Life on Earth is made possible by a multi-layered cocoon of gases, each of which plays a specific purpose and interacts harmoniously with the others. Imagine yourself standing where the sky meets the water on the shore of an unending ocean. The atmosphere is that sky that's above you. It's the air we breathe, the wind that tussles our hair, and the background of each day's dawn and dusk. But air is more than simply air. It's a regulator, a life-giving substance, and a shield. Hi guys, and welcome back to our channel. In today's video, we will see why no human has left the Earth's atmosphere. Let's dig into the video. Understanding Earth's atmosphere and space boundaries. The statement that no human has left Earth's atmosphere is technically inaccurate, as humans have indeed traveled beyond Earth's atmosphere and ventured into space. However, if the question is interpreted as exploring why humans have not yet traveled beyond low Earth orbit, or ventured far beyond the confines of Earth's gravitational influence, such as to other planets or deep space, it opens up an intriguing discussion about the challenges, limitations, and future prospects of human space exploration. It's crucial to first clarify what is meant by the terms Earth's atmosphere and space boundaries. The Earth's atmosphere gradually becomes thinner as one ascends higher into the sky. However, it is impossible to pinpoint the exact boundary between space and the atmosphere. Nonetheless, the Kármán line, which is located 100 kilometers or 62 miles above sea level, is frequently called as the demarcation point between Earth's atmosphere and space. Spaceflight past the Kármán line is where we mean when we discuss humans leaving Earth's atmosphere. Many astronauts have flown over this threshold since Yuri Gagarin's famous flight in 1961. In actuality, during the Apollo missions in the 1960s and 70s, people were able to reach the moon and walk on its surface, venturing far beyond Earth's atmosphere between 1969 and 1972. The reality of human space travel beyond low Earth orbit. Given that humans have indeed left Earth's atmosphere, the more relevant question is, why haven't humans ventured further into space, such as to Mars, other planets, or deep space? The answer lies in the complexity, danger, and immense resources required for deep space exploration. To understand this better, it's essential to consider several key factors. Number 1. Technological challenges. Propulsion systems. Strong propulsion systems that can resist Earth's gravitational pull and support lengthy missions are needed to get beyond low Earth orbit. Although chemical rockets, such as those utilized in the Apollo missions, are capable of achieving this, their effectiveness and fuel requirements are constraints. Deep space exploration depends on the development of advanced propulsion technologies such as nuclear propulsion or ion drives, both of which are still in the early phases of research and development. Life support systems. Ensuring the survival of astronauts on long-duration missions far from Earth requires advanced life support systems. These systems must provide a stable supply of oxygen, food, water, and waste management while protecting astronauts from radiation and the vacuum of space. While current life support systems can sustain astronauts in LEO, and during short missions to the moon, they need significant advancements for missions lasting months or years, such as a trip to Mars. Radiation protection. Beyond Earth's protective magnetic field, astronauts are exposed to high levels of cosmic radiation and solar particles. Prolonged exposure to this radiation can lead to serious health risks, including cancer, radiation sickness, and damage to the central nervous system. Developing effective shielding and radiation protection strategies is one of the significant challenges of deep space travel. Number 2. Logistical and financial constraints. Mission duration and resources. Depending on the mission profile, missions to places like Mars can take anything from a few months to more than a year. This calls for a significant amount of fuel, in addition to sufficient supplies to keep the crew going for the duration of the operation. A manned Mars expedition is expected to cost between tens and hundreds of billions of dollars. As you can see, the costs of such missions are enormous. International collaboration and competition. Space exploration has often been driven by international collaboration, as seen with the International Space Station, or ISS, and competition as evidenced by the space race. However, these efforts have primarily focused on LEO and the Moon. Expanding human presence beyond these areas would require unprecedented levels of cooperation, funding, and political will, which are difficult to achieve given current geopolitical realities. Number 3. Human health and psychological challenges. Physical health. The human body is adapted to Earth's gravity. An extended exposure to microgravity, as experienced on the ISS, leads to muscle atrophy, bone density loss, and other health issues. Countermeasures such as exercise regimens and pharmaceuticals can mitigate these effects, but long-term space missions pose additional challenges, such as the impacts of prolonged isolation and distance from Earth. Psychological well-being. The psychological impact of long-duration missions cannot be overstated. Astronauts on a mission to Mars, for example, would face extreme isolation, confinement, and communication delays with Earth. Maintaining mental health in such conditions requires robust psychological support systems, which are still being studied and developed. Number 4. Scientific and strategic priorities. Focus on LEO and lunar missions. Human space exploration has mostly concentrated on low Earth orbit since the Apollo program's conclusion, especially with the building and maintenance of the International Space Station, or ISS. This emphasis reflects both on scientific objectives, such as researching the effects of microgravity and advancing research that improves life on Earth, and strategic aims, such as international cooperation in the development of space-based technologies. Unmanned exploration. A significant portion of the solar system's exploration has been carried out by autonomous rovers and probes, like the New Horizons mission to Pluto, the Mars rovers, and the Voyager spacecraft. These robotic missions are more practical and economical than manned missions because they can function in hostile situations for prolonged periods of time without requiring life support. Number 5. Ethical and safety considerations. Risk to human life. Sending humans into deep space poses significant risks, and any missions beyond Earth's atmosphere must be carefully evaluated in terms of safety. The loss of life in such missions would not only be a human tragedy, but could also set back space exploration efforts by decades. As such, space agencies are cautious in planning manned missions beyond Earth orbit, ensuring that all potential risks are minimized. Ethical questions. The prospect of colonizing other planets raises ethical questions about the treatment of any potential extraterrestrial life forms and the environmental impact of human activities on other celestial bodies. These considerations add another layer of complexity to the already challenging task of deep space exploration. The future of human space exploration. Despite the challenges outlined above, the future of human space exploration is promising. Several nations and private companies are actively working on technologies and missions that aim to expand human presence beyond low Earth orbit. Artemis Program. NASA's Artemis program aims to bring people back to the Moon by the middle of the 2020s, with the ultimate objective of creating long-term, sustainable human presence on the lunar surface. Future trips to Mars and beyond will need to use the lessons that Artemis taught us. Mars exploration. Both NASA and private companies like SpaceX have announced ambitious plans to send humans to Mars within the next few decades. These missions would mark a significant leap in human space exploration, requiring advancements in propulsion, life support, and radiation protection. International collaboration. Collaboration between spacefaring nations is expected to increase as space exploration becomes globalized. An excellent illustration of this worldwide cooperation is the Lunar Gateway, a planned space station in lunar orbit that may act as a springboard for upcoming deep space missions. Private sector involvement. The involvement of private companies in space exploration, exemplified by SpaceX, Blue Origin, and others, has accelerated the development of new technologies and reduced the cost of accessing space. This trend could lead to more frequent and ambitious missions, potentially including commercial ventures beyond Earth orbit. Humans have indeed left Earth's atmosphere, but the journey beyond low Earth orbit presents significant technological, logistical, and ethical challenges. The complexity of deep space exploration, including missions to Mars and beyond, has limited human space travel to Earth's vicinity for the time being. However, advancements in technology, increased international collaboration, and the growing involvement of the private sector are paving the way for humanity to explore further into the cosmos. The future of human space exploration holds great promise, with plans for missions to the Moon, Mars, and potentially beyond. These endeavors will require overcoming substantial challenges, but the potential rewards, advancing scientific knowledge, ensuring the survival of the human species, and satisfying our innate curiosity, make the pursuit of these goals one of the most exciting and important endeavors of our time. As we continue to push the boundaries of space exploration, the question is not whether humans will venture further into space, but when and how we will achieve this next giant leap. Earth's atmosphere is a living, breathing entity, constantly changing, shaping our climate and holding the secrets of life. It's the protective embrace that makes Earth a rare oasis in the vast, cold expanse of space, a thin, yet powerful boundary between us and the infinite universe beyond. However, if the focus is on why humans haven't ventured further, such as to other planets or deep space, the reasons are rooted in the immense challenges of space travel. These include technological limitations, the need for advanced life support and radiation protection, and the enormous financial and logistical demands of such missions. In summary, while humans have left Earth's atmosphere, pushing further into the cosmos remains a complex endeavor. The journey beyond our planet's immediate vicinity requires overcoming significant hurdles. But with ongoing advancements and growing interest, the dream of exploring deeper into space remains within reach. Hope this video could help you satisfy your curiosity. Do like, share, and subscribe to our channel. Hit that bell icon to stay updated. See you in the next video.